Good evening to one and all. So in today's lecture class, now we are going to discuss about the stability of a closed loop system. Now what is this stability? Now it is the ability of any given system to attain the steady state condition after passing through several transients successfully. Now we call it as a stability. Now the stability, it can be a BIBO stability, that is bounded input, bounded output stability. Now it is nothing but for a linear time a linear time invariant system is said to be stable if it produces a bounded response to a bounded input. In other words, a system is said to be unstable if the response will increase without bounds or will never return to the equilibrium state. Now just consider this response. Now it is the response of a first order system for a unit step input. Now you can see the response, it has values between 0 to 1. So which means the output is bounded. And also we know that the unit input signal, now it has a value of 1 for all positive values of t including 0. So which means the input is also bounded. So therefore the first order control system is stable since both input and output are bounded. So this, it is an example of a BIBO system. Now how do we classify this stability? Now the stability can be classified into absolutely stable system and conditionally or marginally stable system. Now what is this absolutely stable system? Now if the system is stable for all the range of system component values, then it is known as the absolutely stable system. For an open loop control system, now it is absolutely stable if all the poles of the open loop transfer function are present in the left half of the S-plane. So what is this poles? I'll be just discussing in the further slides. Similarly, for a closed loop system, now the system is absolutely stable if all the poles of the closed loop transfer function are present on the left half of the S-plane. So this we call it as the absolutely stable system, that is for all range of system component values the system is stable. Now the next one, now we call it as the conditionally stable system or marginally stable system. That is, if the system is stable only for a certain range of system component values, then it is known as the conditionally stable system. Now if the system is stable by producing an output signal, now with constant amplitude and constant frequency of oscillation for a bounded input. Now you can see here the output does not reach its final value. Instead, it has some constant amplitude and some constant frequency of oscillations, and it is for a bounded input. Then the system is known as marginally stable system or conditionally stable system. Now the open loop control system, now it is said to be marginally stable if any of the poles, two of poles of the open loop transfer function lies on the imaginary axis. Similarly, for a closed loop system, now it is marginally stable if any two poles of the closed loop transfer function is present on the imaginary axis. So this is the classification. We call it as absolutely stable system and marginally stable system. Now you can see this, it is represents the general form of a transfer function. Now where g of s, it is given by x of s by y of s. Now where you can show this, that is the n of s. Now we call it as the numerator polynomial, and this denominator, now we call that is d of s. Now we call it as the denominator polynomial. So now the roots of this numerator polynomial, now we call it as the zeros of the system. And similarly, the roots of the denominator polynomial, now we call it as the poles of the system. So it is this denominator polynomial. Now this decides the stability of the system. That is, it indicates the location of the poles on the S-plane. Now here n, it represents the order of the system, and this ds, now we call it as the characteristic polynomial. And when this characteristic polynomial, when it is equated to 0, now you call it as the characteristic equation. When the characteristic polynomial d of s, when it is equated to 0, we call it as the characteristic equation. So it is this roots of the characteristic equation Now they determine the stability of the system. Now this picture over here, it clearly shows what is the stability when the poles, how they are located. Now you can see on the left half of the plane of this, it is a S-plane. So on the left hand side of the plane, that is called as a LHP, left half plane. Now here, when the poles are located on the left half of the S-plane, now you can see now we have the poles located on the left half of the S-plane, then the system is said to be a stable system. Now where you can see the roots have magnitude, but it also have some decaying components, it reaches the final state. And here also you can see the roots are slowly dying down and it is coming to a bounded output. So which means the roots, when they lie on the left half of the S-plane, so all these roots, this is also on the left half of the S-plane, the system is said to be a stable system. Similarly, now when the roots are lying on the right half of the S-plane, so these roots are lying on the right half of the S-plane. Now where you can see the response, the output is unbounded, it is never going to settle down. It is unbounded output, and here you can see the oscillations, they are growing in nature. So therefore the output is unbounded. So therefore such a system are unstable system. So therefore if the roots of the characteristic equation, now when they are lying on the right half of the S-plane, then the system is said to be a unstable system. And finally, now you can see the roots are located on the imaginary axis, as we discussed earlier. Now where you can see you have oscillations but with some constant amplitude, now the system are said to be marginally stable system. The system is said to be marginally stable system. So this is how we classify the stability of the system. So to conclude, now the system stability is decided based on the location of the poles of the characteristic equation. Now if the poles are located on the right half of the S-plane, the system is said to be a stable system. If the poles are located on the right half of the S-plane, the system is said to be unstable system. And if the poles are located on the imaginary axis, then the system is said to be a marginally stable system. So thank you for patient listening. Thank you.